Alright, so in this problem, I have 25 to the power of x plus 5 to the power of x is equal to 20. So to solve this, I'm going to first rewrite 25 as 5 squared. So now I have 5 squared to the power of x plus 5 to the power of x is equal to 20. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m. So I'm going to rewrite 5 to the power of 2 to the power of x as 5 to the power of x to the power of 2. So I have that plus 5 to the power of x is equal to 20. Now I'm going to let 5 to the power of x equal to the variable y. So now I have y squared plus y is equal to 20. Now if I subtract 20 on both sides, I get y squared plus y minus 20 is equal to 0. Now I'm going to rewrite this as y squared plus 5y minus 4y minus 20 is equal to 0. Now if I factor out y from y squared plus 5, I get y times y plus 5. And if I factor out negative 4, I get negative 4 times y plus 5 is equal to 0. So now I have y plus 5 times y minus 4 is equal to 0. So now this gives me two equations. I have y plus 5 equals 0, and I have y minus 4 is equal to 0. So y plus 5 I can turn into y equals negative 5. And y minus 4 I can turn into y equals 4. So now remember how we set 5 to the power of x equal to y. So now that we have our value of y, let's first start off with 5 to the power of x is equal to negative 5. So I have 5 to the power of x is equal to negative 5. I'm going to start by taking the log on both sides. So I have log 5 to the power of x is equal to log negative 5. Now if I have something in the form log a to the power of b, I move this exponent of b to the front. So this is equal to b times log a. So log 5 to the power of x, I can move x to the front, so now I have x times log 5 is equal to log negative 5. And now if I divide both sides by log 5, these two cancel out, and I get x is equal to log of negative 5 over log 5. Well, the only problem is that log of negative 5, well, you can't take the log of a negative number, so this is wrong. Now I have y equals 4, so I have 5 to the power of x equals 4. If I take the log on both sides, I get x times log 5 is equal to log 4, meaning x is equal to log 4 over log 5. So this is my answer. Alright, so in this problem, I have x to the power of 3 is equal to negative 8. So to solve this, I'm going to first start by adding 8 on both sides. So then I have x to the power of 3 plus 8 is equal to 0. Now I'm going to rewrite 8 here as 2 to the power of 3. So now I have x to the power of 3 plus 2 to the power of 3 is equal to 0. Now if I have something in the form a to the power of 3 plus b to the power of 3, this is equal to a plus b times a squared minus ab plus b squared. In this case, a is equal to x and b is equal to 2. So now I have x plus 2 times x squared minus 2x plus 2 squared, which is 4. This is equal to 0. So now this gives me two equations. I have right here x plus 2 is equal to 0, and I have over here x squared minus 2x plus 4 is equal to 0. So to start, I'm going to first solve x plus 2 equals 0, which is a simple equation. All I have to do is subtract 2 on both sides, and I get x is equal to negative 2. So this is one solution of x. Now, to solve x squared minus 2x plus 4, I can do this in two ways. So my first method is the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 2, and c is 4. So I have negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times c, which is 4, all over 2a. Now this is equal to 2 plus or minus the square root of 4 minus 16 all over 2, which is equal to 2 plus or minus the square root of negative 12 over 2. And the square root of negative 12, that's equal to the square root of 12 times the square root of negative 1 over 2. And the square root of 12, that simplifies to 2 plus or minus 2 root 3. And the square root of negative 1, that's simply I. So I have this over 2. Now if I divide both sides by 2, I get 1 plus or minus the square root of 3i. So these are my two solutions. Alright, so in this problem, I have 21 to the power of 63 over 63 to the power of 21. So to solve this, I'm going to first rewrite this as 21 to the power of 63 over 3 to the power of 21 times 21 to the power of 21. Now, this is the same thing as 1 over 3 to the power of 21 times 21 to the power of 63 minus 21. Because if I have something in the form a to the power of m over b to the power of m, a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, I had 21 to the power of 63 over 21 to the power of 21. So I rewrote this as 21 to the power of 63 minus 21. Now, 21 to the power of 63 minus 21, that's the same thing as 21 to the power of 42. Now I have this over 3 to the power of 21. Now, 21 to the power of 42, that's the same thing as 21 to the power of 2 to the power of 42. This is 2 to the power of 21. And 21 squared, well, that's the same thing as 21 times 21. So I have this to the power of 21 over 3 to the power of 21, which is equal to 21 times 21 over 3 to the power of 21. Now 21 divided by 3 is 7, so I have 7 times 21 to the power of 21, which is equal to 147 to the power of 21. Now I actually have a second method of solving this problem. So again, I first start with 21 to the power of 63 over 63 to the power of 21. Now this time, I'm going to rewrite 21 to the power of 63 as 21 to the power of 3 to the power of 21. Now I have this over 63 to the power of 21. And now this is equal to 21 times 21 times 21 to the power of 21 over 63 to the power of 21, which is equal to 21 times 21 times 21 over 63 to the power of 21. Now this is the same thing as 21 over 63 times 21 times 21 to the power of 21. 21 over 63 is 1/3, so I have 1/3 times 21 times 21 is to the power of 21. 1/3 times 21 is 7, so I have 7 times 21 to the power of 21, which is again 147 to the power of 21.